The next question of Coaches Starters 114 is rock, paper, scissors. So basically, in this, there are two players, Chef and Chefina. They are playing rock, paper, scissors. So there are n rounds in the game. So rules of rock, paper, scissors are rock can beat scissors. Similarly, scissors can beat paper, and paper can beat rock. So this is how the game is played. Now, for the end rounds, uh, all moves of Chefina are given. What will Chefina play? It is given in the form of a string, and the string will obviously contain some characters from this set only, R or S or P. Now we should say what, like we should say a configuration for Chef for the end rounds such that he'll score at least uh, he'll score more than n by 2 points. Like it's floor division of n by 2. So we should say some configuration of Chef where his score will be more than n by 2 at least. So he'll get a +1 score if he plays rock and Chefana plays Caesar in any round, or he plays Caesar and Chefana plays paper, or he plays paper and Chefana plays rock in any round. So now there can be many such uh, many such sequences for Chef to get at least to get more than n floor part of n by 2 points. Among all those, we should say which is the lexicographically smallest one.
And if they both play the same move?
Yeah, if they both play the same move, then no one will get any point. It is considered as a draw according to the rules. So if we look at the constraints, there are test cases. So test cases are can be in the range 1 to 10 power 5 inclusive. Similarly, n can be in the range 1 to 10 power 5, which is number of rounds. And AI is the string given. So ith character of that string can be anything in this set R, P, or S. And it is guaranteed that sum of n over all test cases won't exceed 2 into 10 power 6.
So yeah, let's understand how we can solve this question with the help of a test case. So we have a string of length 12, and this is the string. So now, what is the lexicographical order with S, R, and P? Right. So P, uh, basically P, R, and S. Yep. If you go with alphabetical order, P comes first, then comes R, and then comes S. Yep. Right. So we'll always try to give priority to P because we want to obtain the lexicographically smallest string. Right. Yep. So let's go about this in a brute force way. I mean, let's go about this in a very greedy approach. So let's just try putting all the P's in the beginning, right? Yeah. So let's just try putting all the P's in the beginning until a point where we cannot put more P's. Yeah. And we need to put something else in order to win, right? Because maximizing the number of P's in the beginning will always lead to lexicographically smaller answers, right? So let's say I put P in the beginning. Let's say I put P in the first place, right? Now the question is, can I win this game by putting anything else in the remaining part of the string? And the answer is yes, because we can always choose to win because we already know what Shefina's moves are going to be. We know if it's a rock, I'll put a paper to win. If it's a paper, I'll put a scissors to win. So I can always choose to win. So the number of points I can get by choosing some part of the remaining string would be basically n minus I, where I is the position. So starting from 1 till n, right? So I know I can get n minus I moves if even after putting P till the I places, right? Yeah. And now, since I want to find the lexicographically smallest string, I'll find the point till where I can put as many P's as possible, right? So let's dry run that on this test case. So if I put I'm sorry. Basically, if I put 2, 3, or 4 P's, let's say, then I have this string. So paper wins against rock here. So we get 1 point from here, and we get 12 minus 4, 8 points from here, right? So in total 9 points, which is still more than n by 12, right? So we move a few steps ahead. Let's say we go to I equals to 5. Okay. So now we pick up this part. Okay. Here we get 1 more point, 2 points here, and remaining 7 points there. So 2 plus 7, 9. We still get more than n by 2. We put a paper here as well. We get 2 points from this part and 6 points from this part. Then we can put paper here as well. We'll get 2 points from here and 5 points from here. 2 plus 5 is 7, which is still more than n by 2. Now we can put another paper here, which gives us 3 points from here and 4 points from the remaining part. Right. Basically 4 points from the remaining part. So 3 plus 4 is 7, which means we can still win. Let's see, I'll put another paper here now. Now here I still get 3 points, and here I also get 3 points, right? So at this point, I get an answer. I get the number of points as 6, right? 3 from here, 3 from here, 6, which is not sufficient for a win because we need more than n by 2 points, right? So at this point, we stop and we say that whatever the previous step was there, that's our answer. I mean, that's the point where we stop, right?
Then we increase speed.
Exactly. So that's the point till where we just keep putting P's, and after that, at every point, we just put opposite to. We just put what it requires to win, right? So till this point, we put all P's, and then here we have scissors, so we'll put a rock here. We'll put another rock here. You have a rock here, so we'll put paper, and here we have paper, so we'll put scissors, right? So basically, we keep going, and we just keep putting paper. If Shafina has put rock, then we'll increase the number of points on the left side, and the number of points on the right side will always be the remaining length of the string, right? We just add both of those values, and we just compare it to floor n by 2 value. Okay. So yeah, in this test case, the answer will be this string, basically, and the time complexity of this code will be O of n, because we are just running a simple loop and we are keeping track of the number of points on left and the length of the string on right. Yeah, that's how we solve this question.